Okay, in this video, I'm going to use Python to make one turtle move at a constant motion, and then another turtle move following this equation right here, VF equals VI plus AT. And the user can change the input for the acceleration. I'm going to make a constant time of 10 seconds this is going to run for, and I'm going to make them both start at 10, and we'll talk about pixels in a second, but 10 pixels per second, changing this velocity that we're going to see going through this 10-second interval. So we have this Replit that you can just click on if you go Control and click on it. And it's going to take you to this screen right here. From this screen, you can fork the Replit, and what forking does is it just copies the code so that you can change it, and it doesn't alter the code that I created, but you can change anything on here and then kind of see what results. From here, what you're going to want to do is you're going to want to run the program. And when you run the program, you're going to see the screen that's created by this turtle graphics module. I'll talk more about that in a second. You see two turtles. You're going to have the blue one that's going to move at a constant velocity. Here it says they're both going to move at 10 pixels per second. And pixels just has to do with the amount of screen space that is being lit. But it's going to run for 10 seconds. One's going to stay at 10 pixels constant velocity every second to the right. And then the other one, I'm going to choose, and I can choose right here how many pixels per second do you want the acceleration, so I can make it 10. If I make it 10, you'll see that every second that this goes on, this red turtle is increasing its lead on this blue turtle because its acceleration is changing its velocity by 10 more pixels every second. So this one's always going 10 pixels. This red one, 1 second later, is going 20 pixels per second. 2 seconds later, 30 pixels, 3 seconds later, 40 pixels, and we'll see more about that. And so I can change a bunch of things. Here it says, do you want to retry this or to run this again? And if I go ahead and put yes, it starts back over at the beginning, and I can make it, if I want 0 acceleration, you can see what happens there. Both these turtles are going the exact same velocity. So once again, this is going to run for 10 seconds. I didn't give too many inputs to the user, but you could change it and make it so that you can change the time that this runs for different things. I could try this again. I can make the acceleration negative, and what you see is there's both going to start with a positive forward velocity. So if I change this acceleration to negative, let's say -4, what's going to happen is 1 second later, this blue one's going to be going 10 pixels per second, and this red one's actually going to be going 6 pixels per second, then 2 pixels per second, and you'll see what happens as it goes. So this one actually starts going backwards as that acceleration becomes, well, the acceleration is always changing by -4, so it goes forward and then starts coming back. But there's just more and more to that. But let's just go ahead and look at the code and see how this is functioning. So here is the code. Once again, just directions. You'd fork the REPL, then you could play it, or you can mess with the code and then play it. Here's the code that I used, and I'm going to talk through and break down the code. And so in programming, a few things that we're going to see that I'm going to talk about are the term class, and this is just a blueprint. It has a bunch of code it's the blueprint that defines an object. Like, let's say dog has 4 legs. It's furry. It's certain velocity, certain speed that it can run. Well, a class comes in with all these different factors inlined, and then what you can do is you can take that class and you can make a specific instance of that class called an object, and then you can make that class not just do what everything in the class does, but you can give it specific attributes, its own properties. So I gave those two turtles that you saw earlier, the initial velocity was the same, but then I allowed the red turtle to change its acceleration, and you can see the interacting turtles, how they're comparing. We could consider the blue turtle as a control group in this. So let's look through it. First of all, I imported some information. I imported modules, and this is just programs already done. So I don't have to program from scratch how exactly to make a screen, how exactly to do a bunch of things this turtle is going to do, it comes in with the code and it's called a module. So I imported these modules and parts of these modules. I imported this module called time. This allows me so that I can have increments of a second, and I can change those increments if I wanted to. And then I created an object. So I took that screen class, which just defines what a screen looks like, and I made that screen class or screen class an object, which just named it screen with a small s. In program, you'll see the classes are get the capital S. But now I have this instance of that screen. I have the screen object, and I'm going to give it a width of 800 and a height of 400, and you'll see how that works in Turtle. I'll also take those two I'll make two separate turtle objects. One I call Tim, and that's the red one. I should have kept this color red, but it's the red one in the picture which you are going to alter the acceleration on. And I made another turtle which I call Terry. And the only real thing I did different in these two is I made them both with the turtle module. You can have different shapes. I could add a circle. I could add an arrow that they start all off with. They kind of default to an arrow, but I made it a turtle. I made Tim red. And I also made Tim pen up because this is something that he would have drawn a line as he went if I didn't pen him up. Did the same thing with Terry, but Terry, I went ahead and made Terry's object of that class blue instead of red. So now you can tell the difference between the two. So let's just look further in the code. A little bit more about this whole screen size and how in the Turtle module, how it works. If the screen width is 800 and the height is 400, well, the center of the screen, unless I change it, I can alter this and I can make it different. But in general, if you don't change any settings, the center of the screen is going to be 0, 0, just like in math. And then since the width is 800, it'd be negative 400 to the very left side for x, plus 400 to the right side for x. And then for the y, since height is 200, 0 is the center point, 200 up, and then y could be negative 200 for 200 down to the bottom of the screen. And so you'll see that I placed Tim and Terry over here in a certain location. I'll get back to a screen that looks like this in a second. But going forward, some more information. There's this thing called commenting out. If you comment code in Python, you do a little hashtag and then a space is common, but you really just need the hashtag. And this code's not going to be run, but this is just me saying that, letting myself know that I'm using the equation final velocity equals initial velocity plus acceleration times time. And then just to give the user a little bit more information so they have something going on in their head, I have just a print statement in Python. This is how you do a print statement. Also a little bit more that I did here. I have it so it's a little cleaner looking by allowing separate lines. This /n will create separate lines. Just more on Python if you're taking a Python class or learning more about Python, how the print statement works. There's a certain way you have to produce you have to type things out. So for print, you'd have print, open parentheses, quotations, things like that, close parentheses, just what the Python program is looking for to know when things are starting and ending, just part of the code. But I printed out that statement so users knew what was going on initially. I then made this Boolean. A Boolean is just something that's a true-false statement. It's either true or false. And I allowed it to start off as, I went ahead and made it equal to true, so that I can later on use a while loop. And this is a conditional statement. For conditional, this is not saying that while game on is equal to true, but while game on has a condition where it is true. So it's not setting it to true. This is just checking, and it was true in the first place. I set it to true here. And so it's going to start on because it's checking condition if it's true, and it is. So it's going to do a little bit more. And it's going to do all this code. I'll talk about this code individually. But then also after this, it allows me to say, do you want to try this again? So you don't have to restart the program every single time to start over. It allows us to stay in the while loop until the person would say no, and then the game on would be false, and this while game on is now false, it wouldn't go through the loop anymore, and it'd be done. So I'll talk a little bit more about some of the other things you see here. So let's say we start off with the game on being true, which happens. The condition is true. So Tim is going to go to this position -300, -20, and Terry's going to go to this position -320. So let's see where that looks, where that ends up being. So Terry's going to be somewhere around here. Once again, -400 is the entire screen, so it's going to go somewhat back, not to the very end, and it's going to be a little bit above the y-axis, 20 pixels above, and then Tim is going to be below 20 pixels, just to give them enough spacing so you can see the difference while they're going. And so they're going to move pixels, they're going to be moving pixels to the right based on their velocity, and their acceleration will change that velocity. So you'll see if you give Tim an acceleration, it's going to be getting faster and faster and increasing that distance on Terry because it's always going to be going faster, covering more meters per second. Okay, so we define, just like in math, in physics, we're defining the starting variable. I made the starting variable 10. I'm going to make them both start at 10 meters per second. Well, in this case, it's going to be pixels per second because we're going across the screen. I allow the user, and so here I allow the user to create an input of how many pixels per second they want the acceleration to be. So this is going to be equal to the acceleration variable. But another thing that I have to do here, when I write a string and input string like this, it would take that whatever you typed in, it would see it as a string, and string is not a number. It's like it's just, well, it's not seen as a number that you can use mathematically. So I actually have to turn it into integer so that whatever user inputs becomes a number that can be used mathematically. I set the time equal to 10. This is something else that you could change if you want it to run for less time or more time. If you have less of an acceleration, you might build changes to make this more time. I also have to define a separate thing. So this is actually my time. This n right here is how many minutes went on, because I'm going to have time count down from whatever the user wanted, and as that counts down, it's going to add time to the actual past time. So how many seconds we've been through, and so you'll see how my equation slightly changes from that VF equals VI plus AT. So going on, looking at this part, so we start off while we're making this while loop, while the time is greater than 0. So as long as it's greater than 0 and it starts up here at 10, we are going to do this equation. But I'm going to go ahead and every single time we go through this while loop, I'm going to add 1 to n. So n was initially set at 0 up here. I had to find it at the variable is 0, and then I add 1 second to it. And so after 1 second, you have initial velocity of 10. You have an acceleration of whatever the user put in, let's say 10, whatever they put in here, and they're going to multiply that by how many seconds have gone by. So once again, the first second, it would just be 1. The second while loop, it would be 2. The third while loop, it would be 3. And all it's going to do is it's going to make Tim move forward by that velocity, by the result of this equation from all of these, the input and then the constants I started off with at the beginning. And Tim's going to move forward by that velocity for that second. So velocity is how many somethings per second, in this case pixels per second. So for 1 second, since my intervals are going to be set for 1 second, whatever that velocity is, it's going to move that distance in that next second. Whereas Terry, I could have just put VI because it was defined up here as VI equals 10, but I went ahead and just put number 10. But if this was VI, it would have done the exact same thing, because nowhere in the code is changing the VI. The only thing that's changing in this equation is the n that changes the VF as a result in this loop. And so as I go through the loop, that 10 now is going to increment down. And so what I'm doing here is minus equal 1. It's just saying I'm going to set this new time to 10 minus this 1, and it's now going to be equal to 9. So the first loop through is equal to 9. The second loop through is going to be equal to 8. So just the same thing's happening here. As the actual time passed is incrementing up, the time down here is incrementing down. And this is, fairly new to programming, so this is pretty rough code. There's probably better ways to do some things, but this accomplishes the purpose. And so the time's incrementing down so that at some point in time, we're going to be done with that 10 seconds, and this while loop would be over. Also, another thing is just to keep the pace, that time module I imported at the very beginning. This allows me to do this time.sleep. So what it's just saying is that every time we do this while loop, we're going to wait a second before we do the while loop again. wait another second to do the while loop again. If I change this to like 0.1, it'd wait 1/10 of a second to do the while loop. But I want to increment it in per second, so pixels per second, and this is what accomplishes that part right here. And I actually have it on the next slide with some arrows to it. So here I'm using that time loop, so that's incrementing by 1 second, then it's moving based on the velocity per second, it's moving that much for the next second and going over and over and over through it. And then lastly over here, so that you can change the acceleration and see it run again, I have this is a while loop that's just allowing the turtle to move. So as you're watching the turtle move across the screen, this while loop's going on, but then when the turtle's done moving across the screen, for this part right here, it's asking you, okay, now do you want to try it again? And if you try it again, it's going to go ahead and reset everything. It's going to move the turtle. If you look back up here, it's going to move the turtles back to their starting position. It'll give them the initial variables, initial information we did before. It's pretty much just going to do the same thing again. And lastly, do you want to try this game again? If you say yes, it doesn't really matter if you say yes. If you say anything other than no, it's going to run it again the way I have it. So I have a if without the else. If you see n, and you can type in a capital or lower n, this extra piece of code right here, dot lower, is a function that turns whatever is inputted into so it's looking for a string. That's why this has to be this way. Once again, with coding, you learn a little bit more. Not going to go through everything in here, but it's going to make it lowercase. So if I used a capital N, it would still turn into a little n, and then this would, if again equals no. So whatever this input that you put in, if it's equal to no, the game on is going to be false. So either capital or lowercase, because it's all going to turn into lowercase n. If you typed in an n, the game on is now false. And when you go back to the while loop right here, game on is now false. So we're still in this loop. We're not going back to game on being true. We're going to stay in this loop. Goes back up to here. It sees it as false, and it ends the program. One last thing with some code editors and the players, the screen will just appear for a second and disappear unless you have this exit on click. So this is something that on Replit, I don't think it needs. It will still open and run without it, but in another code editor that I used, I needed that. So that's pretty much the program. Looking at the equation a little closer, once again, VF equals VI plus AT. N is the actual time passed, and that's why I changed the T to N over here in the equation that the Python was actually using. VIs tend to start. So looking at that, so if I take A and I say the acceleration is 10 to start off with, the initial velocity is 10 because it's 10 for everything, as you see in these three spots right here. But then this acceleration, if I put it in as 10 for the first second, this final velocity, or the velocity is good, the displacement is going to move per that second is going to be 20 pixels because of this code, which is just a result of our VF equals VI plus AT. And then the second, we accelerated now 20 meters per second past that initial 10, so we're going 30. So I say meters because I'm used to physics, but pixels for programming. It's moving pixels across the screen. And then the next, then it goes to 30 pixels per second and accelerates by 10 more pixels, once again seen in this part, now accelerating for 3 total seconds. So now you have 30 to add to that initial 10. It's going 40 pixels per second. So once again, that's the code. We can watch it run again. Stop it. I could run it again. I guess I could have just hit yes. I can change the acceleration of 1, and then I can watch the result. So this is after 3 seconds, that first turtle is now going 40 pixels per second and then 50 pixels per second. You can see as its lead keeps on increasing, this first one never catches up with it. And I'm not going to try it again. And look, watch, if I type a capital N, it doesn't matter. Now I'm out of the program, and that's it.